Today we're going to be talking about parallelograms and their different properties. By definition, a parallelogram is going to be a quadrilateral with two pairs of parallel sides. So if we look at this diagram here, we see we have a quadrilateral. Quadrilateral is a four-sided figure, and a parallelogram means we have two pairs of parallel sides. So I could even go in and put my marks to indicate that these two sides would be parallel, as well as these two sides parallel as well. And really what this is coming from is several sets of transversals and parallel lines. I could actually extend this, and I would see that I could have several parallel lines and several transversals here, and I'll see those properties emerge that we studied back with our angles and parallel line relationships. So let's take a look. One of the properties is that diagonals will bisect each other. The diagonal, this one, running from vertex to vertex, and then the other diagonal from this vertex to this vertex, they bisect each other. Remember that bisectors cut each piece in half. So this part of the diagonal is congruent to this part here. And for my other diagonal, it's also bisected, so I have this piece is congruent to this piece here. I also know that consecutive angles are supplementary. Recall that supplementary means that those angles sum to 180 degrees. So if I think back with my parallel line and angle relationships, I'll notice that this angle and this angle here would make consecutive interior angles with these two parallel lines, or also they could be called same side interior. And consecutive interior angles are supplementary, and that same property holds true with our parallelograms. Opposite sides are congruent. So if I look here, this side is congruent to this side over here, as well as the top side would be congruent to this bottom side here. Opposite sides are congruent, as well as opposite angles are congruent. So I could look at this angle here with the one arc mark, and I know it's congruent to the one angle here, one arc mark. And this angle with two arc marks I know would be congruent to opposite this angle here. Also, I will draw in two arc marks. So our properties of a parallelogram again: the diagonals bisect, consecutive angles are supplementary or equal to 180 degrees, opposite sides are congruent, as well as the opposite angles are congruent. Let's look at some examples. We'll do one from each set on your homework. If we use the diagram at right to answer this first question, let's find the length of JM. We're given in this parallelogram JKLM that LM is 86 millimeters and LK is 100 millimeters. So let's think about those properties. I know that LM is congruent to JK, and I know that JM is congruent to KL. My question is asking me for the length of JM. So if I'm already given that JM is my unknown, but I know that LK is 100, then my answer, JM, would also be 100 millimeters. Let's look at one from the next set, 6 through 10. Given parallelogram ABCD, let's find each measure. So for my first problem in this set, number 6, I'm looking for the length of AE. AE, if you'll notice, is part of this diagonal. From our properties, we know that diagonals bisect each other, so that must mean that AE is congruent to EC. So I'll just set up that equation. So that means that my y plus 10 must equal 6y. Simplifying and combining like terms here, 10 equals 5y. And then solving for y, I get y equals 2. And substituting back in 2 plus 10, I find that my distance AE, that segment length, is 12 inches. Go ahead and finish all the problems on this front page. You can complete 1 through 10, and we'll see you in class.